Okay, in this part of section 3.1, I want to talk about the derivatives of exponential functions. So remember what exponential functions are. Exponential functions are functions where we have a base, a, right? And the x is up in the exponent part here. So they're sort of the opposite in the sense of the power functions that we started talking about, right? The power functions have x in the base and a number in the exponent. These guys are the opposite. The base is a number and the x is up in the exponent. And remember, for the bases, we talk about positive bases, right, not equal to 1. So that's what this applies to also. Okay. All right. So the problem that most students run into here in these exponential functions is that they try to apply the power rule to these guys. And again, the power rule only applies when x is in the base and there's a number in the exponent, which these things aren't. So if you want to take the derivative of an exponential function, what you have to do is use this rule right here. And so you can see to take the derivative of an exponential function, essentially all you do is rewrite the exponential function and multiply by the natural log of the base. So let's look at a specific example. Here's a specific exponential function, 2 to the x, and I want to take its derivative, right? So again, that's an exponential function. The base is a number, the x is up in the exponent. So you must use this rule, right, as opposed to the power rule. So this rule says to take the derivative of 2 to the x power, I just simply rewrite 2 to the x and then multiply it by the natural log of the base. So in this case, natural log 2, and that's the derivative of the function 2 to the x. All right, let's look at a really special example, and that special example is the natural exponential function, e to the x. Okay. So again, that is an exponential function. E is a number, right, an irrational number, and so that's why we use the symbol e for it, and then the x is up in the exponent. So you must use this rule to take its derivative. So, all right, so using that rule, we would get this, that f prime of x is equal to e to the x times the natural log of e. Well, the natural log of e turns out, right, because ln is log base e, and I'm taking that ln of e, right, that number is just equal to 1. So this whole part right here is just equal to 1, and 1 times e to the x is just e to the x. And so we get a really, really nice property about e to the x. It's its own derivative. And so there's no function that's easier to take the derivative of than e to the x, right? All you've got to do is rewrite it. You really don't do anything other than just write it down again. So you may have wondered, you know, in previous classes, why do we use ln and e as the bases of logarithmic and exponential functions as opposed to other nice numbers like 2 or 10, right? And this is the reason why, basically, is that of all the exponential functions, e to the x is the one that's easiest to take the derivative of. For all of the other exponential functions, we have this annoying ln of the base that tags along with it, but e to the x, right, has a nice, easy derivative here. It's the best function to take the derivative of. So if you've ever wondered that, like I did when I was taking those classes, this is the reason why. It has a nice derivative. It's nicer than the derivative of any other exponential function.